So we have this question which is on the distance between 2 points on a grid circle. Now don't forget that we have a grid circle when 2 points are on the longitude or are on the equator. I hope you've not forgotten. Now let's take this question together. So we have two locations on the equator are on longitudes 50 degrees west and 30 degrees west respectively. If r equals to 6,370 kilometers and pi equals to 22/7, we are expected to calculate the distance apart along the equator correct to 3 decimal places. Now let's try to solve this. The first thing we need to do is to represent this on the globe. Now let's try to draw the globe. Now this is the equator at 0 degrees, and then we have the prime meridian at 0 degrees. Now we are told that two locations on the equator. Now I hope you've not forgotten that this here is the equator, are on longitude 50 degrees west. Now west is left of the prime meridian, and we have 50 degrees, so it's like midway through, so we can have something like this. And this here is 50 degrees west. Does this make sense? And then we have 30 degrees west. So 30 degrees west will be still on the left hand side of the prime meridian, but closer to the prime meridian. So we are going to be having something like this. And here we have 30 degrees west. Does this make sense? Now remember, both points are on the equator. So it means that if we want to represent these 2 points, we'll be having one here and then the second one here. Do you understand? So if I want to complete this circle, I'm going to be having the other parts go like this. Does this make sense? And if this is the middle of the circle, the radius will be somewhere here. And then we are going to be having theta. I hope you understand. So we are told that if r is 6,370 kilometers and pi is 22/7, we are to calculate the distance apart along the equator. So we are expected to calculate this distance here, which is an arc. Remember the formula for distance between 2 points on a great circle. Remember, an equator is a great circle. The distance equals to theta over 360 times 2 pi capital R. Now the only thing that will be different is that, remember in the previous video I told you that theta is the angle between latitudes. Now but in this case, because the equator is a latitude, it means that theta would be angle between longitudes. Now you really do not need to cram this, because in the previous video when we have longitude as the great circle, the only difference will be in latitudes. The longitude will be the same. Now in this case also, when we have the equator as the great circle, the only difference we are going to be having would be in the longitude. So it's just common sense. Does that make sense? So our theta will be angle between these two longitudes. Does this make sense? Now we have the longitude on the same side, west and west. And remember, we said when they are on the same side, we subtract. I hope you can still remember. So it means that theta will be 50 minus 30, and this will give us 20 degrees. So it means our theta is 20 degrees. So we have 20 over 360 times 2 times pi. We're told to use pi as 22/7. times capital R, and in the question we're told that we should take capital R as 6,370 kilometers. So we have over 1 over 1. 0 can cancel 0. 2 here 1. 2 in 3 is 1, remainder 1. 2 in 16 is 8. We can have 2 here 1. 2 in 18 is 9. Now we need to do this with a calculator. We have 22 times 6,370. That will give us 140,140 all over 9 times 7 is 63. So we are going to be having 140,140 divided by 63. That will be 2224.444, because we are told to take our answer to 3 decimal places, and these 3 decimal places. So we have kilometers, and this here is our answer. So I think what you need to note in this video is that when the great circle is the equator, theta is no longer angle between latitudes. Instead, it becomes angle between longitudes. I hope you understand.